Okay, here's another example of graphing expanded polynomials. And if you haven't already done the problem, what you can do is you can write it down. F of x equals 3x to the fourth plus 8x cubed minus 21x squared minus 18x plus 8. And then try to go through all the steps we've done in the past and see if you can get a good graph of this polynomial. So if you haven't done it already, pause your video right now and then try it and come back. So pause it now and go. Okay, so hopefully you're putting it back on. Hopefully you tried it and you got a good answer, so we'll check it. Or you might have got stuck someplace, so kind of watch, and if you can get a little bit of hint that will help you continue, then continue. Do as much as you can on your own. That's what's really going to help you. Do as much as you can on your own. Just don't write down what I write, because that's not going to be there all the time. So you have to do as much as you can on your own. So first of all, we check our in-behavior model, and this is going to be positive even, so they're all going to behave. Every positive even function behaves like y equals x squared, and we're up and up. Looks like it's like a u. My y-intercept is when x is 0. So if I put 0 in here, all that's left is 8. So I have the 0.08, so that's my y-intercept. My possible rational roots, those will be factors of my constant term 8. Well, they'll be in the form c over b, where c is a factor of the constant term, 8, and b is a factor of the leading coefficient. So constant term a will be plus or minus 1, 2, 4, and 8. These will be the factors of 8, and the factors of 3 will be 1 and 3. So 1 over 1, 2 over 1, 4 over 1, 8 over 1 would be these. And then 1 over 3, 2 over 3, 4 over 3, 8 over 3 would be these. So we have actually 8. Plus the negative possibilities. So actually we have 16 possible rational roots or zeros. Okay, so we'll go through and get started. And what we're going to do is, since we've got a 3 here, it's highly likely that one of these will be a fraction with a 3 in the denominator. That's how we introduce 3, with a 3 in the denominator. So I'll start with 1/3. And I would try 1/3, negative 1/3, and if that didn't work, then I might try 1. I might go to 2/3, etc. So we'll try 1/3. And here are my coefficients. 3, 8, negative 21, negative 18 1/8. So those go here, and I do my synthetic division. Bring down my 3. 1/3 of 3 is 1. And like I said earlier on the other problems, I did these ahead of time so it wouldn't take so much time to go through them. All right, save a little bit of time. So you can see your synthetic division, how it worked out. So 8 plus 1 is 9. 1/3 of 9 is 3. Negative 21 plus 3 is negative 18. 1/3 of negative 18 is negative 6, plus negative 18 is negative 24. And 1/3 of negative 24 is negative 8. So I got my 0 right away, so I was pretty lucky on this one, right off the bat. And this is my factor, x minus 1/3. Remember, if 1/3 is a 0, x minus 1/3 is a factor. And this is my reduced equation. I started with a 4th power. So my reduced equation will be a 3rd power because I took out 1 power there. So 3x cubed, 9x squared, minus 18x minus 24 equals. And then we're going to set these equal to 0 because we're looking for the zeros. Since we are, I can just divide both sides of this by 3 for just this part. I've already got my factor there. And if I divide by 3, I get 1, 3, negative 6, and negative 8. So I can use these numbers. And this polynomial will have the same zeros as this polynomial. All right? So let's take a look at that. So I tried, first of all, since I did 1/3, I'm going to try 1. So I tried 1 in here. And I use these numbers, 1, 3, negative 6, negative 8. Bring down your 1. 1 times 1 is 1. That's 4. 1 times 4 is 4. That's negative 2. 1 times negative 2 is negative 2. That's negative 10. Didn't work. Then I tried negative 1. Bring down my 1. Negative 1 times 1 is negative 1. And I have 3 minus 1 is 2. Negative 1 times 2, or 3 plus negative 1 is 2. Negative 1 times 2 is negative 2. Negative 6 plus negative 2 is negative 8. Negative 1 times negative 8 is positive 8. Negative 8 plus positive 8 is 0, and that's my other 0 or root. So these are my factors, x minus 1/3. If negative 1 is a 0, x minus negative 1 or x plus 1 is a factor. And this is my reduced equation, which is a trinomial, x squared plus 2x minus 8, and that's a nice simple trinomial, so it's easy enough to factor. And my signs are going to be, this tells me that these signs are different. This tells me the sign of large is positive, so I got positive, negative. Multiply to give 8, different by 2, have to be 4 and 2, unless the larger one. So those are my other two factors. Remember, it's a fourth degree equation. If it's a fourth degree, it's a fourth degree equation. That means we've got 4 zeros, or roots. And 4 factors. So these are my 4 factors, and these are my 4 zeros. X minus 1/3 is a factor, means x equals 1/3 is a root. Negative 1's a root, or 0. Negative 4, just the opposite sign here, and 2. And we had our y-intercept from above. Our y-intercept was 0, 8, so I can put these points. So I drew my graph over here. Oh, this would be x over here. And I marked in my 4 zeros, 1/3, negative 1, negative 4, and 2. So, and this is my intercept. And my end behavior is up and up. So there we go. And I know my low point or high points will be kind of in the middle of these. That's I guess it's going to be in the middle of these 2 points. So we'll go down like this, and somewhere between these 2 points is something like this, and somewhere between these 2 zeros is something like this. So usually the lower high points will be right between two zeros. This is why I use a pencil, so you can kind of refine this a little bit, because sometimes. And something like this. Another kind of W looking type thing. And there we go. That's, you can check this. You can go on a graphing calculator. And just look online, graphing calculator, and then you could put this in, or you could put the form of this in and have them graph it, and you'll be surprised how close we are. So there you go. And again, this could go much lower, and this could go much higher. I'm just kind of approximating, but I know probably the low point will be somewhere right between those 2 zeros. The high point will be somewhere in between these 2 zeros. Low point will be somewhere in between these 2 zeros, something like that. Okay? So if that makes sense. It's not too hard, just a lot of little things, but if you get practice, if you practice these, they're very doable.